Hello everyone, today we'll be solving the problem multi-set. So just give me a second, 1 second here. Yeah, we'll be solving the problem multi-set, right? So this was asked in the this one educational code forces round 87, rated for the division 2, rated for the people who gave the contest who were this one division 2, right? So who are in the division 2. So let's solve the problem multi-set. So you can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem. So just give me a second. Yep. So you can just go through the question as I've said. I'll just summarize the question so that it will be easier for us to solve the problem, right? So here we have two conditions. Before that, we are given a sorted multi-set of n integers. What we have been given? We have been given sorted multi-set with n integers, right? And we need to perform q operations of two types. So we need to perform q operations on the n integers, right? So we have been given sorted multi-set of n integers. We have to perform q operations of two types. One is we have to insert an integer into the multi-set, right? One is we have to insert an integer to the multi-set. First one is insertion. So what is the second one then? Second one is we have to remove the kth smallest element from the multi-set. Kth smallest element from the multi-set. So we definitely we would have been given this one as well. What do we call? N and Q we should have been given, and array and query also we should be given, right? So these things which we should be given in the input output part. First thing is we have to go with the insertion, nothing but insert an integer into the multi-set. Second one is we have to remove the kth smallest element. So I'll just go with here kth smallest element. So this one I'm speaking of kth smallest element in the multi-set, right? Kth smallest element from the multi-set. We have to remove the kth smallest element from the multi-set, right? So just keep this in mind, these two things in mind. At the end, we have to output any remaining integer in the multi-set or 0 if empty. So if the multi-set is empty, then we have to return 0. Always remember this one. This is one of the edge cases as well. If multi-set is 0, then we have to return 0 in that case, right? So just keep this in mind. It's very simple question. Again, I'm going to read this loud. Just remember, just try to understand or remember this one, right? So here we are given a sorted multi-set with n integers. First thing, we are given a sorted set, this one, sorted multi-set with n integers. What we need to do? We need to perform q operations of two types. One is insertion, nothing but we have to insert an integer into the multi-set. Second one is we have to remove the kth smallest element from the multi-set. Basically, it is insertion and deletion, right? Insertion means we have to insert an integer into the multi-set. Second one is deletion means we have to remove the kth smallest element from the multi-set, right? One more thing, if the multi-set is empty, then we have to return 0. This is also one of the important edge cases. Just keep this in mind, right? So this is the question. Simple. So let's move on with the input output part. Let's move on with the input output part. So here we have been given some examples, 3 inputs. So let's go with the first example here. Sorry, just give me a second here. Yeah, let's go with the first example here, this one. So we have been given 5 5 1 2 3 4 5 minus 1 5 times, right? So 5 5, this is nothing but this 5 is n, and this is nothing but q accordingly with the questions. We have been given n sorted, this one, right? Mm, we are given sorted multi-set of n integers, right? N integers is nothing but 5 integers. We should be having 5 integers, right? So here you can clearly see we have the 5 integers. Q is nothing but the we have to perform q operations on this one, q operations of two types, right? So this is nothing but the q, n and q, they have been given in the first line, right? So this 1 2 3 4 5 is nothing but the array. This 1 2 3 4 5 is nothing but the array, right? So array consists of the integers 1 2 3 4 5. N we have been given 5, so obviously array consists of the elements 5, 1 2 3 4 5. This minus 1, what minus 1 5 times what they have given in the input output part, this is nothing but the queries. This is nothing but the queries part, right? So I hope this part is completely clear, man. So this is for the input output part. Same goes with the example 2 and example 3 as well. So here the output that we need to get here is 0. Means multi-set is empty, so we are returning 0, right? So how we got 0? This one, let's discuss that one in the approach. Let's do one thing. I'll just consider the first example for the approach. You can try to do the same thing. Whatever we discuss, you can just try it out the same thing on the example 2 or example 3, right? So that you understand the question better. Your intuition may be better than mine, or you can go with the different methods as well as you solve, right? So now we are done with the question and input output part. So let's move on with the approach, right? So let's move on with the approach part. Right. First, here, what shall we do? First, let's go with the approach followed by the complexities, and then let's write the code. As usual, first let's go with the approach. So I have considered the first example that they have given in the question, right? So the same first example that they have given in the question. N is nothing but 5 here. Q is also 5 here. This is nothing but the array, and this is nothing but queries, right? So the output that we need to get here is 0, right? So multi-set should be empty basically. The same input we are considering, right? So let's move on with the step-by-step explanation. We will be starting with the multi-set 1, 2, 3, 4, 5 because array consists of the elements 1, 2, 3, 4, 5. Our this one input, main input is 1, 2, 3, 4, 5 because n we have been given 5 and query q also we have been given 5. So we have the 5 minus 1s here, right? So this is fine. Let's move on with the first part here. So we will be going with the sorting. In this case, it is already sorted. One, see, this is sorted in the ascending order, right? 1, 2, 3, 4, 5. Array I'm speaking of. So array consists of the elements 1, 2, 3, 4, 5, which is already sorted, right? So let's move on with the query. Query 1, nothing but 1 we have, right? First, what we will do, we will remove the first smallest. So before moving on with the first query, so I want to tell you one thing. So we will be making use of the Fenwick tree. Just keep this in mind. We will be making use of the Fenwick tree to solve this problem, or BIT, right? Binary indexed or binary indexed tree, right? So we will be going with the BIT or the Fenwick tree to solve this problem, right? So let's move on with the first query. We have to remove the first smallest. Means in the array, the first smallest is 1 itself. Now the array consists of 2, 3, 4, 5 after removal, right? After removal, uh, first this one, first smallest we have to remove, right? After removing the this one from the array, the elements that are present in the array are 2, 3, 4, 5. So next let's move on with the again next thing, query 1. So query minus 1 means here query hyphen 1 whatever I have written. So we have to remove first smallest again until uh, until we are left with something, or until we are not left with something, right? So here in this case we will be removing the first smallest. We will be removing 2. So we are left with the numbers 2, 3, 5. 2 is the first smallest number. We will remove 2. Now we are left with 3, 4, 5 in the array. So let's move on with the next step, query hyphen 1 again, query minus 1. So we will remove the first smallest. We have the elements 3, 4, 5. So we will be removing 3 from the array. We are left with 4, 5. We are left with 4, 5. Again we'll move on with the next step. Nothing but we are having 4, 5 in the array. We will remove first smallest again. So 4 is the first smallest element now. So we are left with the element 5. We are left with the element 5, and we will remove the first smallest again. uh, we have the first element, I mean the first smallest element that is present in the array is 5. Only we have only one element in the array, that is nothing but 5. So we will be removing that 5 from the array. Now we are left with the empty array, right? So now we are left with the empty array. For this particular example, we are left with the empty array. So whenever we are left with the empty array, in the question they have said we have to return 0, right? So we have to return 0. In this case, what we'll do, we will return 0. We will return 0. So the output that we got here is 0 because the multi-set is empty. Because the multi-set is empty. You can clearly see here, right? Because the multi-set is empty. So now we got the solution 0, which is equivalent to the output, that they have given for the example 1. Example 1 within the question. Example 1 within the question, right? So our approach works absolutely correct. So one more thing, before moving on with the complexities part, so I want to tell you one thing. We will be making use of the this one, Fenwick tree or the binary index tree, BIT. Why? Because we will be going with the add and remove, right? Basically in the question they have asked for the, as we have discussed, they have asked for insertion and removal or deletion. Removal is nothing but the deletion, right? So for the add and removal method, to add and remove efficiently, so we will be going with a binary index tree or the Fenwick tree. So add of x is, so we can go with the add operation within big of logarithmic NTC or the time complexity, and we can remove the kth smallest element using the lower bound of k in big of logarithmic n as well. So that is the reason we'll be going with the Fenwick tree or the binary index tree. Just keep this in mind. You'll get to know this one. We have already solved the last problem on the Fenwick tree, right? So we should be having some idea. So in the Node.js, I have solved many problems using the Fenwick tree. I have given many contests. So we this time so we should be having some knowledge on the Fenwick tree, right, at this time. So we have solved n number of problems on the Fenwick tree already, right? So we should be having knowledge on the Fenwick tree, so this is fine. Now let's move on with the complexities part. Let's move on with the complexities part, right? So what will be the time complexity and the space complexity here? The time complexity is big of n plus q into logarithmic n, because we are going with the add, and lower bound also takes this one, each add operation. What we'll be going with this, you'll get to know when we write the code. We'll be going with the add method. Each add and lower bound method as well, these two takes big O of logarithmic n, big O of logarithmic n, right? So overall time complexity would lead to big O of n plus q into log n, because n plus q is nothing but for the input what we have been given, number of this one, right, number of elements in the array, nothing but in our example, the example that we considered for the approach, we have been given 5 plus q is nothing but this one q, number of elements in the query. So we were given 5, right? So this one also we were given 5 minus 1 5 times. So n equals 5, q equals 5 we were given. So this would be overall time complexity would lead to big of n plus q into the operations, this one add and lower bound. So we have to insert and remove, right? So for that one it would take big of logarithmic n. So overall time complexity would lead to big of n plus q into log n, right? So what would be the space complexity here? The space complexity would lead to big of n. The space complexity would lead to big of n, nothing but, so here binary index tree or the Fenwick tree uses big of n memory, optimized for less than or equal to 28 MB. So accordingly with the constraints basically, right? So I hope this part is clear, man. I hope the complexities part is completely clear along with the approach. As we are completely familiar with the complexities and the approach, we are good to write the code. Let's start writing the code. So let's start writing the code. I'll just come to the compiler here. So let me do one thing. Mm, yeah, let's start with the main class. So I'll just name the class here main. So you can just go with the any class name, man. You can just go with any class name, so that is relevant to the question. You can just give the question name itself. So I'll just go with the main here. So first let's go with the input output part, nothing but let's go with the fast input reader to avoid the scanner, right? So scanner fast, this one buffered input and the print writer will be slower. So scanner and the buffered this one, what do we call, buffered reader and the print writer will be slower for this particular problem, right? So basically we have been given 10 to the power of 6 here, 10 to the power of 6 here. So let's go with the fast input reader. So I'll just go with static int. So this one will be read int. So let me go with throws input output exception, input output exception. So this is fine. So within this, so what shall I do? First let's go with C. Let me assign this one to the system dot in. This one read, and also let me assign V to 0 and S to 1. So this is fine. So let's go with a simple while condition here. This would be C less than or equal to 32 and C equals, so this will be system dot in dot read. So this is also fine. We are just skipping the white spaces, right? We are just skipping the white spaces here. So first thing, we have to handle the negative. We have to handle the negative. So this one, if C equals hyphen, then what we will do, um, S equals minus 1, S equals minus 1, also C equals system dot in dot read. So this is fine. We are just handling the negative numbers. We are just handling the negative numbers, right? So this is fine, man. Um, then what we have to do, so we have to build the integer. So one thing, I'll go with the while condition here. This would be while c less than 32. Then let's build the integer here within the while condition. So v, I'll just give here v into 10 plus this one would be c minus 0, c minus 0. This is fine. So c equals system dot in dot read. So this is fine. So we are almost done with the input output part here. So we have to return the signed value, right? So I'll just go with a v into v. So you don't have to worry about the input output part that much. So I'll just explain whatever I have been coding now. So this will be v into s. You can just go with a templates or a template of your choice, man. Right? So this is fine. Now let's move on with the further thing. So we have to go with a maximum range value, nothing but for the Fenwick tree size, right? So I'll just go with public. So this one will be static final, and we have to go with the maximum range value, right? So I'll just go with the max in here. So let me go with 000. 10 to the power of 6 we have been given. So I'll just go with 000. This is fine. So let's go with the main. This is fine. Let me remove this one entirely. So here, let me go with throws input output exception. This is also fine. So within the main method, what shall I do? Let's read the initial number count, and also let's read number of queries. So this will be n equals read int. So this is fine. And also we have to read the number of queries. This one would be q equals read int. So this is also fine. The next step would be we have to initialize the Fenwick tree. As I've said, we will be making use of the Fenwick tree, right? So we will be uh, we have to initialize the Fenwick tree. So before initialization of the Fenwick tree, so let's do one thing. Let's write the custom Fenwick tree class, right? So let's go with the Fenwick tree class just to perform the efficient prefix sum and insertions. So we have to add and remove, right? So accordingly with the question, we have to go with the add and remove methods. For that purpose, we will be going with the we'll be making use of the custom Fenwick tree class to perform the efficient prefix sums and insertions, right? So let me go with class Fenwick here. This is fine. Class Fenwick. Within this class, let me initialize. So there's no suggestion for private. Let me type this one. Private int. So this one will be tree. And also let me go with private here int. So this would be n, right? So this is fine. Let me go with a class Fenwick. So I'll just go with public. So this one will be Fenwick initialization part, right? So let me pass the parameter size. This acts as a constructor basically. This one, let me assign into, or let me initialize into size. And also this dot tree, this one will be new int of n plus 1. So this is fine. So we are done with the initialization part. Next, what shall we do? We have to add the value at the index. We have to add the certain value at certain index in the Fenwick tree, right? Particular index at the Fenwick in the Fenwick tree. So let me go with the add operation. So this would be public void add. So the parameters, I'll just go with index and value. So this is fine. So within the add method, what I'll be doing, let's go with a simple while loop here. While index less than or equal to n, what we will do. So within the while loop, let me go with tree of index uh, equals tree of index plus value. So this is also fine, man. So now we have to move to the next responsible node. Nothing but here index equals index plus I'll just go with for addition. So I'll just be going with index and minus index or hyphen index. So this is fine, man. Let me come out of this one entirely. Next, what we need to do, we have to go with the method sum. Means this is nothing but the prefix sum query, man. We have to sum up all the values from 1 to index, right? We have to sum up all the values from 1 to index. For that one, we'll be writing one more method, nothing but sum method. So I'll just go with private here, or let me go with the public, not the private. So public access modifier has to be public here. This is fine. Int sum. So the parameter, I'll just go with the index. So this has to be index has to be type index should be type int. This is fine. So let me initialize the result to 0 as we need to calculate the sum, right? So index has to be greater than 0, quite obviously. So within the while loop, result is nothing but result plus tree of index. We are going with the sum, right? So we are summing up all the values from 1 to index, right? So this one. Next, let's go with the next step here. We have to move to the parent. Nothing but here in this case, it would be index equals index minus. So this will be index and hyphen index. So this one will be index and hyphen index. So we have to move to the parent. So that is the reason I have written this one again. So this is fine. Finally, we have to return the result. We have to return the result. So I'll just go with return. We have considered res, right? Variable. So I have just written that one, right? So let me come out of this one entirely, man. Now we are done with the method sum as well. Now what we need to do, one more method we have to go with, that is nothing but the lower bound. Lower bound means removal or the deletion part, right? So we have to find the smallest index such that the prefix sum is greater than or equal to k, right? So we have to go with the parameter k, and we will be going with the lower bound method, nothing but the removal or the deletion part, removal of the kth smallest element, right? So we have to find the smallest index such that prefix sum is greater than or equal to k. This is accordingly with the question that they have given, right? Accordingly with the question, and also accordingly with the approach that we have discussed, right? So this one will be public int. So this one is lower bound. So let me go with the parameter. Okay, let me go with the parameter. Okay, so this one will be int index equals 0. This is fine. Let me go with the variable name bit here, nothing but the binary index tree. So this one will be integer dot highest one highest one bit of, let me pass n here, let me pass n, nothing but we have to start from the highest bit, right? Always. So bit shouldn't be 0. So let's go with the while loop here. While bit not equal to 0. So within the while loop, what we'll do, let's go with the simple. Hmm, before going with the if condition, let me initialize next to dex plus bit. So this is fine. Now let me go with the simple if condition. Next less than or equal to n, and tree of next. So this one less than k. This is also fine. Now we have to move forward, nothing but k equals k minus tree of next, key of next. We have to move forward. So idx, nothing but index equals next. This is fine. Next, what we have to do, we have to check the next lower bit. Check the next lower bit, nothing but I'll just make use of the right shift operator for that. We have to check the next lower bit, right? So that is the reason I'll be making use of the right shift operator here. So this is fine. The final step, we are left with only one thing, nothing but we have to return one based index here. So as we are initially, we will be with the zero based indexing. So we have to return based on the one based index, right? So let's go with index plus 1. So here it is nothing but I have considered the variable name idx plus 1. So we are done with the Fenwick tree, custom Fenwick tree class, right? So different methods that we have written here as add, basically add some, add and sum. This is related to the insertion, and for the removal we have written the method lower bound, right? So simple to understand, very simple to understand, right? Now what shall we do? we have already written the custom FinVictory class, right? So that FinVictory class, let's make use of it in the main method. Let's make use of it on main method. So I'll just go with FinVic uh, f equals new. This one will be FinVic. Let's pass max on this one, right? So let's pass the max and nothing, but we are initializing the FinVictory here, right? So we are creating the instance, right? So this is fine. Let's insert the initial n elements into the FinVictory. We are going with the insertion part. Let's insert the initial n elements into the FinVictory. Let me go with the for loop here. Int I equals 0. This is fine. I less than n and I plus plus. So within the for loop, what we have to do, we have to go with the frequency plus 1 for each value, plus 1 for each value. Also one based indexing, we have done that one within the lower bound method, right? So now we have to go with the frequency plus 1 for each value. So I'll just keep here, we have made use of the readint, right? So yeah, readint. So this one, comma 1, comma 1. Right, so this is fine. Let me come out of this one entirely. Now we have to process the each query. Now we have to process each query. Let's go with the for loop here. This one int I equals 0, I less than q, I plus plus. So this is fine. We have to process the each query and nothing but q that we have been given in the input. So we were given 5, right? In the particular example that we considered, q were given 5. The values minus 1 5 times, minus 1 minus 1 minus 1. That is nothing but the query. We have to process the each query, right? So that's what we are doing here, right? So we have to read the query first. We have to read the query first. So I'll just go with x equals again readint. After reading the query, if the value is positive, then we have to insert the x into the multiset. If the value is positive, then we have to insert the x into the multiset. In our case, we were left with this one. What do we call? Empty multiset, right? We were left with empty multiset, so we inserted this one 0 in the question. They have been given if the multiset is empty, then we have to return 0, right? So here in this case, if the value is positive, then we have to insert x into the multiset, right? So if x is nothing but the integer here, if x is greater than 0, then what we need to do, we have to add, if the number is positive, we have to add that one into the multiset, right? I'll be making use of the add operation here, x comma 1. So this is fine. Else what we need to do, if the value is negative, if the value of x is negative, then we have to remove the xth order statistic, right? Then we have to remove xth order statistic, nothing but the kth smallest element. How can we write that one? We have already written lower bound method for the removal, as I've mentioned this one several times. So this is related to add and sum is related to the insertion. Lower bound is nothing but this is related to the this one removal. Add we have already made use of somewhere. This one just now I did. This is add method. This is for the insertion. Now we have to go with the removal. Nothing but if we get the negative value, if the value of the x is negative, we have to remove the xth order statistic. Nothing but we have to remove the kth smallest element. So I can just write it in this way. Int value equals f dot, this one will be lower bound. I think, but just now I showed the lower bound method, right? So we wrote that one for the removal itself. So this will be, we need absolute number, so I'll be making use of math.abs of x. So this is fine. So the next step would be, we have to reduce the frequency of that value, nothing but f dot add of val comma minus 1, val comma minus 1. We are reducing the frequency of that particular value. We are done with the we are done with this part, right? So let's move on with the further steps. We are left with the only this one, printing the output part. This is related to the input output. So one thing I have to tell you is, after all the queries, after processing all the queries, so we have to find the smallest existing number, right? Nothing but we have to get the first element in the multiset. We have to get the first element in the multiset. For that one, let me initialize the result, or let me assign the result to f dot lower bound. for the removal, we have already written lower bound method. So we have to get the first element in the multi-set. So let me pass 1 here. So we are left with only one thing, nothing but this one. We have to display the, or we have to print the result, right? So for that, I'll be making use of the system out println. So I'll just go with println, system out println here. If result, this one, if it is equivalent to maxn, we'll be making use of the ternary operator. Maxn plus 1, because we are going with a 1 based indexing. Then we have to display 0. 0 means here, maxn means here this one. If we are left with the multi-set, if we are left with the empty multi-set, then we have to return 0. If we are left with the empty multi-set, then we have to return 0. Else we have to return result. Else we have to return result. So this is the result, right? So this is it, easy, right? So we are done with the coding part. We are done with the coding part. Let me do one thing. Yeah, before checking the code with the different inputs. So let me copy paste the signature starter template. Just give me a second here. So let me come here. Let me paste this one entirely. So let's concentrate on the further steps. So we have to check with the different inputs, right? Code. We have to check the code with the different inputs. Output that we need to get here is 0. Let's check the same thing. Let me hit the run button. So we are getting the, again, did I misspell anything? Cannot find the symbol where? Line number 20. What is wrong here, man? So here, let me go with the exception rather than the input output exception. We are only dealing with the exception, right? So, oh, exception part. Now we have, yeah, this error is gone. Again, line number 36. This one also, let me go with exception only, not the input output exception. So let me run this one again. So we are left with some 7 errors, okay? So here cannot find the symbol. Where line number 22, x less than or equal to 32. So what have, not x, man, this is c actually. Did I type as x? So while of c less than or equal to 32, then we are assigning c to this one. Just to skip the white spaces, we are making use of this line, right? Particular line number 22. Now let me run this one. This error has to be gone. Yeah, we are left with 6 errors. Mm, non-static variable, this cannot be referenced from a static context, right? So which one? New Fenwick. Fenwick, just give me a second here. Okay, 1 second. Line number 40. So within the Fenwick custom Fenwick tree, whatever we have written class, I have not made use of any static this one, right? So we are making use of this one. So just give me a second. The line number 40. So here we are going with the, just give me a second here. We are going with the static void, man. So currently I'm not understanding what is wrong here. So let's move on with the this one next error. Let's try to clear the next bug. Here we have incompatible types. Int cannot be converted to int this one array. So somewhere I have written wrong, I think. So let's check this one. So what is happening to this? Just give me a second. Line number 65. So this dot n. So yeah, for this one in the line number 62, this is not array. N is nothing but the number of elements. We have been given array. We don't have to go with the array here. So we just have to initialize n. That's it. So let me run this one now. This error should be gone. So yeah, we are left with only error. Oh, 5 errors are gone. This is fine. We are left with only one error, nothing but non-static variable cannot be referenced from a static context, right? Non-static variable, this cannot be referenced from a static construct. This one we are writing within the static context itself, public static void main within the main. So here we have not referenced what this thing. Let's check what is wrong. So in the line number 27, we are building the integer man. This has to be greater than this one 32, not lesser than 32 basically. So input output this one. Again, we are still left with the same error. This is fine. This we have corrected this one. Non-static variable. So I'm not getting this one where I have to change man. Just give me a second. So what mistake I have done here is, so I have included this class Fenwick tree class actually, whatever the custom Fenwick tree class we have written within the main method. Within the main method, this has to be outside the main method. One thing that we can do here is we can add a static here. So if I try to run, I don't know whether this works or not. We are getting the output 0. This also we can do. Just let's check with different inputs as well. So we are getting the output 3 here. This one also, let's check this one. We are getting the output 1, the wrong answer, right? So here we have to get the output 6. Let's do one thing. Rather than the static keyword, this shouldn't be static basically. So here, let me do one thing. Let me remove this bracket. So let's keep this one out of the main class, right? So let me paste it over here, right? So let me run this one. Now we are still getting 1. Static was working, I think. Static keyword also works basically. Now let's check what is wrong, man. We have to get the output 6 for this, but we are getting the output 1. Let's check what is wrong. So I think what I have done here is we have made use of the lower bound, right? So lower bound of 1 we are giving somewhere. Where is this one? I forgot completely, man. Just give me a second. Somewhere we have made use of the lower bound of 1. Just give me a second. So yeah, here we are giving a lower bound of 1, right? So this will take the smallest number actually. This will take the smallest number out of this one. When we give this input, 1 is present basically. We don't have to go with the 6 itself. 1 is the smallest element that is present, I think. So here in this case, 1, the output 1 is also correct, I believe, rather than 6. The one output 1 is also correct for whatever we have written, I believe. Let's check this one. If it doesn't work, then we can change the code, right? So I'll just come here. Let me copy this one. Let me paste it over here entirely. I hope this works, man. Let's see. This, yeah, accordingly with the question, this has to work because we are considering the smallest accordingly with the approach as well. Instead of the 6, 1 has to work as well. Let's see. It can have the multiple outputs, but let's see. So we are getting the wrong answer, man. We are getting the wrong answer basically. We are getting the answer 310. What? For which one we are? We are. Sorry, just give me a second here. Have submitted answer to the wrong question, I think. So let me submit this one here. Yeah, question itself. Some previous question I had submitted, I think. Sorry, yeah. Now this is running on the test one. This has to work for one as well. Let's see. Let's wait for some time. Running on test 3, running on test 5. Let's wait for some time. So we have purely made use of the this one custom Fenwick tree class here. Means we have went with the Fenwick tree mainly. That's it for this particular problem, right? So nothing else. Yeah, for the insertion and the deletion, right? So we have went with the Fenwick tree. That's it. That's all. That's what they have asked in the question as well. Just for the sake of this one optimization part, we have went with the Fenwick tree. So you can just solve the problem with the other methods as well. So Fenwick tree works absolutely fine here. So I can clearly see here in the toast it is showing accepted, right? In the toast it is showing accepted. So whatever the code that we have written works absolutely correct for all the test cases, right? So we are done with this problem, right? So we have made use of the fin victory basically, or the binary index tree, to solve this problem, right? So I hope the solution part is completely clear, along with the approach and the complexities. For now, this is it. Thanks for watching, guys.